mostly they fit into this same structure. Now, Luminous doesn't have any opinions about. Actually, I think it does. It does mention test-driven development is a good thing, but it doesn't like enforce anything. So we'll just go ahead and move forward here. So what you see in the editor here is the top-level directory of our project. All right. So this is what you get mostly when you pull from Git, when you clone it. And I believe you said you've already done that, so this should be familiar. And we'll go through and explain, and be sure to ask any questions along the way here. So, and for those who may be watching this as a recording, some of you are working on projects which, like YVideo, which is based on the same structure, the back end of YVideo. So the things that you see here will hold mostly for that as well. Okay, at least the back end things. All right, so we have a few extras. So things like .carve and .eastwood, those are part of our testing framework. And so you don't need to directly be concerned about those. Those are used by the Carve program and the Eastwood program to do static analysis of our code base to make sure the code stays high quality. So they don't directly play, and some projects don't have those. That was something we've added more recently. All right, in env here, you have environmental variables. So this is intended to be a place in which you put things like database passwords and other information that your instance needs that shouldn't necessarily be public. And so let's see if I can pop that open. So here in env, we've got the different profiles that you can run with. So when you run in line again, you can choose which profile you're using. And really what the main thing is doing is deciding which one of these env folders it's going to be reading from. So when you just run a REPL on your own machine, you're running in dev here. And so in dev, you've got the stuff under CLJ, CLJS, and resources. And so there's not much stuff in CLJ and CLJS. So users.clj, that's something that is automatically loaded into your REPL when you start. So if our project decided that for development, there was something we really needed just for development, that's where we'd put it. Okay. The main one we do use quite a bit is resources here. And this is where you have your credentials. So we also have logback XML. That's one of the things that comes with Luminous, but that's essentially saying how some of the testing is supposed to be set up. So we started using alternative testing, and I don't think we've got around to deleting logback yet. We should probably do that. If you're using so logback is a Java JUnit XML testing setup, and being JVM, Clojure can readily use that, and it does that out of the box. That's something Luminous does. We've decided instead to use a complete Clojure solution for our testing called Timber, which actually Luminous at some points in history has used that instead anyway, but we like it, so we've gone that way instead. The other thing that matters, though, is the config.eden. Eden is the Clojure data structures. In some ways, it resembles JSON, but it's a little more full-featured than JSON is, and it's actually the language that Clojure itself in your code files is written in. So there are certain Clojure things that won't work in Eden. So for instance, Eden cannot contain functions, but it can contain data. And so we have the config Eden and the config sample. Since this is a recording, I'm not going to look at the full Eden, but we'll look at the sample. So the sample is inside the version control. And so you've got this. And it shows you the structure of what the config Eden should have. So it's going to have a couple booleans. The port here is just read by the program later in code that you could change if you wanted to, but it means that this is when you start the REPL and you tell it to start the server, it's going to use this port. And so you'll say, take my browser to localhost 3000. And that's where this port comes in. And that'll be your application. Don't care. Well, nREPL port is used, but we don't need a lot. We don't run live REPLs. Site URL needs to be here. That's for bounce backs with things like the CAS logins. So it knows where to send you back to after you've gone off site to use the service to log in. So in dev, that's going to be localhost something or other. And in prod, that's going to be our actual website address. So that's the way we've coded our authentication to think. All right, and then you have the stuff under the actual app here. So in this case, flats. And here is the nested map. This is the database. And so this is all the things required to make the database work. So actually, we need to work with you, Easton, and with everybody who's coming on board on this project to get you the prod version with the actual credentials so you can actually set up the database. Now, in fact, better yet, and this is something that if Nate were here, he would tell you, and I'm sure Yuri, I think I've heard it from her too, set up a local Postgres instance. It makes everything so much better. So if that's a big problem for you, then we can go ahead and work on setting up a dev one. But that means you can only connect when you're online. It's pretty slow for our processes because some of the tests have to do thousands of interactions with the database, which is slow over the net usually, and so on. So getting your own local version of the database is really the way to go. And so this is a Postgres database. Has to have, well, some of these are required, some of these are optional. Of course, the host and the username, password, those are required. And these are all things that the database connector is going to use. Then in here we have auth, which is our one-step authentication that we use in the Flats application, which is magic.io. And so these are things that our third-party API needs to know about us, like what's our token. And so not as much in all of our applications, but in the other ones that I work on, you make heavy use of third-party stuff. That's kind of the name of the game in web app development. And generally, they require tokens and passwords. And so this is the place where you put those. Files, if you do, so in our case, we do some file I/O, either reading or writing things directly to the actual disk of whatever server it is. So it's important to remember that when you're doing a Java application, you're running the JVM and you're going to be running it generally, at least the way we do it and the way most of the time it's done, through a jar or WAR file online, so a package. And that means that if you say my location, if you just in your code say something like /files and just write to /files, if that works at all, you're not going to be sure where it goes because you can't actually write to things inside your archive. So this is something outside your archive somewhere on disk. All right, so that's the config Eden. Do you have any questions about the config Eden here?
Not specifically, no.
Okay, this is kind of a crucial thing for the brain of the system. Now, there's another way to do configs, and sometimes this is strongly recommended. So it's suggested that you instead encode your config into the environment of the server you're on. And so the system we use, Mount, it can read those the same as it reads the config. In fact, it does. And so you might not have even known that, but you can put stuff in the config of a Linux machine and say something like flats_password or something, and then inside your Java app, it's going to have that. The reason we don't do that, though, is because we are running on shared servers. And that means that it would be just kind of an ugly mess to have all the different applications sticking all their stuff into the server config. And so it's much easier for us to keep it right here in the project. But once again, the actual filled out version of this file is not going to be in version control because you never put credentials in version control. So it's going to be something we need to get to you.
Okay.
Actually, we actually probably don't need to get it to you because, like I mentioned, set up your own database and you just put in your own credentials. You don't care what everybody else did. So it just needs to be a Postgres database. All right. So that is the env resources. And so now we are ready to look at some of the code here. All right. So you've got, of course, the GitHub. I'm not entirely sure. I don't remember what that is. That might be the documentation. Get stuff, line stuff. We don't care about any of those really. Log. This is in development because obviously this is something that lives inside this package. And so on prod, it better be doing something out of that config Eden to decide where to put things because you can't put them inside the project. So that is something we'll have to make sure. Yuri, do you know if that's set up correctly?
About the log?
Yeah.
I think so, yeah. You just...
So it's looking in config Eden?
Yeah, I'm not entirely sure, but
Okay, yeah, we'll just want to double check that at some point. Okay, Markdown, that might be a leftover. Yeah, that's a leftover from a long time ago. We don't really need that. Some PDFs that you don't care about right now. Okay, in any project in Clojure, you're going to have some key files, and Luminous is using, at least it was when we made this, the Leiningen tool, which is the same one you've been introduced to, which is a startup and dependency tool and project management tool for Clojure. I like it, even though it has some tendencies to be kind of a Swiss Army knife, like an everything in one, which is not always the best idea, but we do it. So Project CLJ, if you're not familiar, this is one of the crucial things in a Clojure project. So this is saying the name of our project, some stuff about it, and then the dependencies. So at this point, everything in here is required. So in the dependencies are all the libraries that we utilize throughout the code. Now, occasionally there might be some that we don't utilize and we got to trim them out, but it takes some careful work to do that without destroying your program. So now beside each dependency, you see the version number as a string following it. There are automatic tools that will update this and that you use that version number to decide what to get. So that's actually a crucial part here as well. There are automatic tools to upgrade all your dependencies. You just have to be ready to rewind if you do that, because it could break stuff. So in the Clojure realm, usually it's strongly recommended that you don't make breaking changes, that you make changes to like whole new versions, but especially during development, that's not always the way it works. So we've got all the dependencies, lots of those. Okay, then we get into a few more things. If you're using Leiningen, you got to have this version. Now, Eastwood, we mentioned that file earlier, the Eastwood file. This is information that Eastwood, the program, is going to need when it does static analysis on your code. Source paths. These are, when you start the REPL up, these are the places it actually looks for the things on the JVM class path or for the JavaScript. So you can't just stick a code file anywhere and expect it to run. It needs to be in the right places, and that starts with these source paths. So you see here that we've got src CLJ. Those are the backend files, the ones that compile down to Java bytecode. And that's where our server lives. We've got src CLJC. Now this is Java, so not Java, sorry. Clojure has the power to compile to both Java and JavaScript, same language. CLJC stands for CLJ common or cross. It used to, in old days it was CLJX, but CLJC means that this is where it's going to compile stuff it finds here to both. So anything under this path is expected to work on both the front end and the back end. So certain things like application-specific data wrangling software. So how do I dig into a certain kind of map to find a certain kind of value? That's the kind of thing that belongs here because it's totally Clojure, no libraries involved. I don't think we have too much that we're using in CLJC on this project right now. And finally, as you would have guessed, CLJS is the Clojure script. This is where our front end comes from. So this is the stuff that's going to compile down to JavaScript. Resource paths. So this is two things. So resources right here, this points to, at the service directory, a file that we'll get to is the directory resources. And this is where you put things like database migrations, as well as things like style sheets and images that need to be public. There will be a subdirectory in here called public. And so resources/public is going to be your public stuff that your web browser can hit. That gets actually hosted by the server. And then target CLJS build. This is where the Clojure script compiler sticks its output so that you can have hot loading. So that's also crucial. Target path. Now you're probably never going to mess with target path, but this is when you build your jar file out of all your stuff. This is where it's going to stick it. So if you ever get to the point where you're writing the shell scripts that deploy or utilize that jar that comes out, you've got to know where this is, because this is where it's going to put it. Main tells it which function it's going to start with. Test paths. So this relates to your earlier question of the tests. So the test paths, the tooling we use in Emacs Cider is aware of your tests. But to be aware, it has to have these things here saying, here is where the tests for this project live, in these 3 subdirectories under test. So we have unit tests, we have use case tests, which are similar to integration tests, if you know that term. And then we have the UI tests. So those ones have been a little less defined for this project because this one doesn't have such a heavy front-end application dependency that we need heavy testing there. But some projects use a lot of front-end that's very intricate, and on those ones you want tests to make sure nothing has destroyed it. So we'll look a little more depth at those as we go. JVM options, the test selectors, these are telling you which ways you can run line again test, and it will use something that it says here. So it's going to read this. Again, you don't really care about that, but that's just what it is. Plugins, we've got things that, these are line again plugins. So for instance, there's one that, so line again can build your Clojure script. That's what this is. And then ones that we don't use anymore, we've got the line garden. Garden is the software used for CSS, but since Garden first came out, there's become a better way than to use the line plugin. We don't need the plugin anymore. So Hiccup Bridge, I actually don't remember what that one is. We don't use that one anymore. We need to clean this up a little bit. We don't use iMutant anymore. Cloverage is for coverage testing. So seeing how much of your project actually has coverage in your tests. How many functions are tested. Okay, again, we don't use iMutant anymore. We use Garden, just not the Garden plugin. So here's details that a Garden for CSS needs to know, including when it builds your CSS, where does it go? So you should be seeing a theme here that Clojure very often builds things in other languages from the Clojure. It does a lot of transpiling, especially to JavaScript and to CSS. The things it does to HTML are a little higher level, so they don't actually produce HTML files for us, but they could. Okay, and then what happens when we clean it? So we want to clean everything pretty much. More stuff on where things come out when we build them. And then Figwheel is the live process and REPL that our program uses to connect here. To connect to a REPL, I should say. So it's especially for the front end. And so it watches the CSS directories. So if you make a change that produces a change in this directory, then your browser will automatically pick it up because Figwheel is watching this directory. In line again, you can run things with the profile. So we can say how we want to build things, and the profiles can in turn come from project things. So for instance, again, this is dev. So these are the things that are there when you run your local REPL. These are the things it uses. And then all of its build dependencies. So how does it build the Clojure script? Like this. And here's where it says, okay, I'm going to take the env dev seal.js. We looked at that folder a minute ago. This is where it's telling it, I look there. This is one of the places I take into account. So, and by the way, from our last week's, our last meeting, you should be recognizing here, like we said, everything is vectors and maps, and this is all vectors and maps. Square brackets and curly brackets, and then keywords. Vectors, maps, and keywords, and strings. So that's what this is. Okay. So it's a fairly big file. It does a lot of different things. Any questions about how this works?
Once again, not really in specific, no.
Okay. Now you're probably going to have questions as you do more development because this is a very important file. So
Right.
don't hesitate to ask. But for now, you don't need to do any changes here. In fact, I can't. So Yuri, when's the last time you made a change to Project CLJ?
So it's like we had a reformation update. I changed the version.
Yeah, we did some version updates, and that was it. So have you ever had to write an actual new line of anything in here?
No, actually. Or like if I had a new dependencies. But bottom line, like here, I've never really touched it.
Yeah, so things will work fine for you. You might never have to touch this. So, but you still need to know how it works, because if you have problems or if you start your own projects, you're going to need this. All right. Okay, we hop back out. We've got some shell scripts here. So these are shell scripts that are used for deployment. So as we mentioned, we have a Jenkins deployment that makes continuous integration for us. And that deployment process uses publish Jenkins. So again, you don't need it at all. You don't need it locally. But when we publish it, this needs to be there. Same with publish prod. This is the one that you use locally to say, well, it's the one I use. I don't think you need this at all. But it's the one I use to say, okay, looks good. I'll put this somewhere. And actually, now that we have Jenkins, we don't need this much either. But I used to. Same with publish staging. So those are leftovers that I can probably get rid of, actually. But they're shell scripts that non-Clojure things utilize in order to build our Clojure project. readme.org, if you're not familiar, so .org is an Emacs file format that GitHub happens to be fluent in. It's in several ways better than a Markdown. So that's your README. Resources, we mentioned this for like public resources belong in here, as well as your SQL stuff. SRC, if you've ever done any Java, that should be familiar to you. But our project.clj had a resource path, and those resource paths all start in SRC because that's where our code is at. So we're coming back here in a second. Target, as you recall, is where it compiles things and puts them when it's done. Especially the jar files, war files, and Clojure script, or JavaScript files. So things that need to be published end up going in the target directory. And then the test directory is where our tests live. And then usage.org. I do not remember that file. So cool. All right. Looks like it was made in February. But anyway, okay. So where would you like to go from here? SRC or test?
Test. Definitely test.
Okay. Let's hop into test. All right. So in test, we have tests for JavaScript and for Java. Now, we don't have much in the way of JavaScript tests because this project doesn't need that much. So we don't have too much in the JS area. So we'll look in the CLJ. Now here we branch three ways, and this is one of the things, again, that we do differently than Luminous ever considered. Luminous doesn't break things down this way. But we found it very useful to break things into three categories of tests. So when you're doing actual UI tests, it's going to run a headless browser that actually clicks its way through your application. And so that's under UI. Unit tests are where you're going for that coverage. You're just saying every function should do what it's supposed to do. And so all the functions should have unit test stuff. Now, under here, it's important to know the structure. So things under unit test, you want your application, so Emacs Cider, to be able to be smart about your tests. That means that they need to match the directory structure so that the namespaces work. And we'll talk more about namespaces as we get to one of these. Okay. Here's a good example. So I've jumped down under unit test and flats, and we have all of our files right here. So we'll start with handler test. Now notice this is namespace flats.handler-test. So that's or the file name is handler_test. Now Java is very picky about class names, namespaces, and file names. And so this is where it actually comes in. This part is Not optional. You have to get this right or else things will break. All right. And so remind me, Easton, have you dealt with Java very much? I think you've done some of the early classes in them, right?
Yeah, I've done Java.
Okay. So you probably know something about how it has to have file names certain ways.
Yeah.
So one thing that's a big kind of a nuisance to the Clojure community, Clojure takes the same philosophy as all Lisps, because in addition to liking parentheses, we like dashes. We like dashes better than underscores, but unfortunately, Java does not like dashes. It does not allow dashes.
But isn't it just translate a underscore as a dash? Or
in our code, we tried to do that.
Right.
Inside the file names, we have to have an underscore in the file name, handler test.clj, and it has to turn out as, let me fix that, handler dash test. So this has to match that file name. And then flats dot, because you saw, so the SRC had the resource paths that were SRC inside our project CLJ. So resource path was SRC slash or tests slash. And so that means that the next directory it finds after that path needs to be flats. And in the file system, it's slash. So it's a directory. In the namespaces, it's dot. Flats dot or slash handler underscore or dash test. So this is one of the only really obnoxious parts about the syntax here, is because you're kind of working around the JVM a little bit. So you have some requirements there.
So you said you could put a dash or an underscore?
No, not in the NS. So in our code, we try to make sure you can use either one, but really dashes are the way to go. So the idea is that in the code, when you're actually looking at Clojure code like we are right now, you should never see an underscore.
But would it fail to compile if you did an underscore?
It would be, usually it'll be something different. So an underscore just is a different character. So it's not going to be the same thing. So for example, we have flats.db.email-log. If that was email underscore log, it would fail because that's not a valid Clojure namespace. All right. So here we are inside of our test. This is our NS statement, so namespace. So Clojure makes heavy use of namespaces. I think Java gets a little bit of that right too. Namespaces are a good idea in programming in general. That's one of the shortcomings of JavaScript, is that it doesn't do real good namespaces. So anyway, back to Clojure here. You have a requirement. So these are the things that this file is going to need. And so we have some tooling that gives us the underlining here. And so you should definitely catch up with Yuri if you haven't figured out how to set that up yet. So that's Condo, and it's extremely helpful for making things smart here. So I think the setup that I worked with you to download and install this morning, you might not have this yet. So you might need to build this because there's an external program that does this. So you get the underlining here. What these are telling me at the moment is that, oh, I have things in this project. I have Proctor info is one of my namespaces I'm using in my requirement folder or my requirement statement here, but I don't use it in my code anywhere. That's what the underline here means is, hey, do you really need this? However, if you do need something, it has to be here. So you're not really hurt other than code sanitation if you have extra stuff here, but you break if things aren't here. So that should be familiar. All right. So we've got our requirements. The other thing that could be in here would be things that you import. So this would be actual Java classes. If you're using Java libraries. On this project, we don't have to do that very much. So any questions about the namespace?
No.
Now, one thing we like to do when we write namespaces that we don't have here, but we should, is an addition here, excuse me, of the doc string. So you'd say something about what this namespace is about, like what's the idea? All right, now we get into the testing. Oh, the one other thing I'll point out about this, you have requirements, and you have two options that we use here. You've got as, keyword as, and keyword refer. Now, as means that whenever I'm getting a function out of Cheshire.core, if I simply have the requirement statement, the require statement, then in my code, I could write Cheshire.core / parse-string or whatever my function is.
Mm-hmm.
That's a pain. That's a lot of writing. So as just means I can do JSON / parse-string. Refer is something to be careful about, but it means that for these ones, I don't need any preface at all. It's going to pretend these are from this namespace. So I only need to type def test or is or testing or are. I don't need anything before that to make them work. But they're actually coming from the Clojure.test namespace. And all of these dependencies either need to be something that's included in Clojure, or they need to be something from that project.clj we saw a minute ago, where you have that huge list of dependencies. You need that to be in place before you can do stuff in your file. So that's the way those work. Okay. So refer and as, we've got our various things. Here's the Timber logging that I told you about. Here's mount.core. So sometimes you just need to include something in a file that's going to be loaded just to make sure it gets put onto your Java class path. So that is sometimes why you have something without an as, because you're not actually going to call it, but you need it to be on the class path. All right. Now we have a macro here. It comes from up here. You can see, let me, all right. So up there on line 17, you can see where we required TU. So here we are using that as TU. I've got a TU /, and then this is a macro that we wrote for our project here. It starts up a database fixture, meaning that anything that happens in here is a fixture that's going to be rewound. So you can make changes to your database, you can delete stuff, you can add things, whatever. When you're done, it'll be as if it didn't happen. So for testing, this is pretty vital. Clojure has the do command. So technically, you wouldn't need that because you could just have all these things floating. But since you have a do command, you can hop to the closing parentheses and you can evaluate everything inside there all at once, which means in one command, you can have all of these things evaluated. So when you're going through by hand, you don't have to go one by one to do these. So as you work with your test more, that'll make sense. The important thing to see here is what it's doing. So MIG, we have that earlier, that's our migrations. So it's going to clear out and refresh the database. So it's going to make the database totally fresh. Again, that's a reason that doing a local database is way faster than doing an online one, because if you're doing the remote database, it takes a long time to do the renew. I think Nate was last telling me that it was like 5 minutes for renew at least. So 5 to 20 minutes. So that cleans out your database. Then we're going to get a test. We're going to make some things in the database. So you may be enough familiar with tests to know that you have fixtures in which you set up all the scaffolding you need to make your test work. So we need certain things in the database, or else we can't test getting things or deleting things, or if our credentials work. So I can't say get me the next question of the test if I haven't told it about a test yet. All right, we have some helper functions here. So this is a mock JSON request. This is going to be used in the tests, but so remember, so this is a handler test. This is testing the API of the server, and so we're going to do things like JSON. So we're going to be pretending to be the front end, making calls to the API. So in this case, those calls may come through as JSON, and so we've got various things that they could be. It could be a patch request, or otherwise just a general request. All right. Now we get into the actual tests. So we have def test. So that's the main keyword when you're writing a test. And then you give it a name. So DB language is route. And then you have the option of using the testing keyword, which is followed by an explanatory string, and then the actual meat of the test itself. So we say, okay, this is going to say return good responses for all languages, and then we have a let statement. So this is also important to know as you get started with Clojure here. We use a lot of lets. Lets, have you used these in another language? JavaScript now does them.
Yeah, I've used it in JavaScript before, but I actually don't really follow what it does in JavaScript as well as I did in Clojure. But
So in
I assume it's
JavaScript,
pretty
then,
similar.
yeah, if you used them in JavaScript, you probably are more familiar with var.
Yeah.
Yeah, so it's very similar, except that the scope is different. So a let says input, when route and request and response, all those things I'm letting in this vector, is followed by a vector of pairs. The first thing is the name of the, think of it as the var, the name of the var, and the second thing is what the value to go with that is. And they're only defined within these parentheses right here, within the let itself. So this is how we're setting up our variables. And in this version, so in the Clojure version of Lisp, these are done sequentially. So if I say input up here, I can refer to it down here. And that's valid.
Okay.
And then I make the request, and then I want to make sure, okay, when I do this mock request, remember we're doing these mocks here, and it's convention of ours. So this is unit testing, which means that the test lines up with an actual namespace with real stuff in it. We, as a convention, we like to call that real namespace subj, so that it's this. So it's easier to copy and paste your tests because they're always saying subj, even though which one is subj changes depending on the test you're in. Does that make sense?
Mm-hmm.
Okay. So this is only testing one thing. It says, is our response a good? Is it a 200 for when we do this mock request? And this means that we're expecting that. Now, if it fails, and I don't have it set up here because I don't have a database set up on this machine, I don't think. So I can't actually run this test. But if I ran it and it failed, I would get a pretty window popping up that tells me the string that I had here. And it tells me you were expecting 200, but you actually got whatever. And so that's the way it works. And you see Yuri on your head because she's done a lot of these. These are very handy. They're very useful. And so we're just going through the same functions that we saw elsewhere, or that we've written elsewhere, or possibly. So in test-driven development, you're going to write these tests before you write those functions. So you may not even have in your head yet exactly how those functions are going to do it, but you write yourself a test saying, well, however it works, this is what I need the output to be, and this is what I need the input to be. And then your goal becomes, let's just make the test pass. That's the goal. All right. So we get through. Now, these are the main things we use. There are some other available keywords. You can have, instead of is, you can use are for multiple things. We don't generally do that, though, just because it's a little harder on the tooling and it's not really necessary for our stuff. But you can have multiple is statements, and they will be parsed properly. So you can see that in line 107 down here. A bunch of is, and like we mentioned, the kind of comments you get out of the report at the end saying these assertions have passed or these ones have failed, and we'll give you the details. So the last argument is, the first argument should be the test you want. So is 200 my status response? Now, if not, it's going to post this string. There we go. This string is going to show up in your report at the end. And this is very handy both for that reports processes. So if something fails, it'll say exam answer is proceeded successfully, but then it failed. So it'll say, okay, that's what should have happened, but I've got a problem here, and that's exactly what the idea here is supposed to be. So it's documentation to the reader, and it makes the test make sense. So it's not required, but it's a good idea to have the final argument of your is statement be a string that explains why you're testing this thing and why it should pass. So that's the basic syntax, and that's a pattern you'll see repeated. So here's a new def test, which is generally the name of the function dash test. Now your tooling needs it to have that name because there are places where you can say, take me to the function that goes with this test, and that's how it's going to find that. So once again, we've got testing. We set things up in the let, and then eventually we get to the is. And that's the pattern.
Okay. And you can have multiple of these like testing blocks inside of a def test, right?
Yes. In fact, you can have multiple inside each other. But that makes reading the report a little harder. Like it gets ugly if you do too much nesting. So better to keep it shallow.
Okay.
But yeah, put as many as you want in. And as many is as you want is fine also.
Okay. Will it run until just one of the is's fails, or will it run all of them?
It runs as many as you tell it to. So when you run your test thing, let's see if I can. Okay, I can't at the moment. So when you look in the Cider test commands, there's a lot of stuff here. And some of them you never need to, many of them you don't need to know. But one of the ones that's valuable is Cider auto test mode. So, and I'm not, do you ever use this, Yuri? Do you know about this one?
I don't know. I was do the keyboard controls, CU, I can't remember. But
yeah. Okay. So that's the manual testing, and that's the one to start with. Auto testing is great for TDD. Because remember how we mentioned that the name of the file needs to match the name of a normal namespace file? That is the test for. And then the functions hope to match the functions in that other file, maybe with the test or maybe not. Auto test mode makes it so that whenever I do a REPL evaluate the file, so maybe I've made a change and I say evaluate the whole file again, Control-C, Control-K, it's going to automatically at that point run the tests that match. So every time you do that, it runs your test and tells you what passed. So you're trying to make your test pass, and that's how you're trying to develop. That's a great way to do it. Okay. So you have a few options here, and these line up with several things from the keyboard that are sometimes available. You can do Cider run test, which means, in this case, it would run the test I'm in right now. Not the testing, but the def test. So it's going to run the test I'm in right now, along with whichever scaffolding needs to take place to get that set up. Various things that match. So I'm looking for... Oh, so one of the reasons it doesn't have any keyboard shortcuts set up for me is because I don't have my REPL started yet. So you remember from last time we talked about how to start the REPL. Now these tests, we're not doing any front-end tests, so I don't need to start the front-end REPL. I'm only going to do the back-end REPL, Cider jack in, which is the same thing as Cider jack in CLJ, I think. And so it's going to start the REPL, which sometimes takes a moment. And I can't remember if I've got a database set up, so it may not let me do very much, but you can at least see me get around. Okay, so it's taking a moment there to start the REPL. Meanwhile, we can see these tests here. There, and that wasn't too bad. There's a REPL, and I'm going to say start, which reads our config Eden, and also starts our server, and connects to our database, and so we're ready to go. It'll yell at me here if I don't have a database. Apparently I do, so it didn't yell at me. That's good. Okay. All right. So now that I have this running here, still not showing me the commands I was hoping for the test, but okay.
Wait, are you looking for the command, keyboard to run the test?
So because of the way I'm sharing my Emacs screen, I can't actually use those keyboard commands. So that's why I'm doing it this way. So. But we can't see them listed here. All right. So these are all the various Cider test options. Now, there's the two you're going to use the most probably when you're doing this by hand. The one you use the most for sure is run ns tests. So that means the namespace that I'm in right now, run these tests. So it said no, it didn't find it because in the project skill J, where we say our class paths for the SRC, the testing here is not on that path. So it said, hey, the REPL doesn't know this namespace because I don't have that. So I just evaluated it. I think I evaluated the namespace. No, I did not. Okay, and remember, so this morning I was talking to you about how Emacs and Clojure are kind of like cousins. Like Emacs is basically a big REPL. So I'm looking for the command eval buffer. Emacs has its own command eval buffer for evaluating Emacs code. That's not the one I want.
Oh, okay.
I want Cider eval buffer. Says I made some changes like that namespace I added. Yeah, I'm going to save that. Now I ran it. Now the most important thing here, nothing changed, but now it knows the namespace, which means that now I can run our test stuff. All right, so run ns tests, and it says that it's running those. It'll take a second because it's doing all the database stuff. It's doing a bunch of stuff. And now you see on the right, I just got my pop-up for what were the results of this file. And let's see, so a couple of things to notice about the pop-up here. So I got 15 failures out of 41 assertions. So some things passed, some things didn't. And here we go. Let me hit, I think I can hit enter on this guy. And it takes me directly to that result. And it says, oh, you were expecting a 200, but I actually got a 403. And the problem is, it turns out 200 is different than 403. So that's the problem. So then at that point, you can start proceeding here. Now, when you set up auto tests, you're going to be getting this window with every evaluation, and you're going to be reading it to follow what exactly is going on. Even if I'm not in a test folder anymore, it's still going to be telling me that stuff. And I could go to the test folder at any point. So you can proceed to the next thing. Nope, not with that command. So same problem here. We got a 403. And that's probably because my dev environment may not be set up right. Here, there should be two things that got added to the database, but it says there's nothing in the database. So that's a problem. And so you're seeing the process here. And so if I were to try and debug this, that would be very useful to me. And so you see, the other thing to look at here is, let's see, you see the blue string matches. So that's where this string right here comes into play, is the explanation right there, which in turn is underneath return the testing explanation right here. So that's where these two strings are used. And then, of course, you have, here's the name of the test, and here's the name of the test again. So there you go. All right. Any questions about testing?
Not a big. I think I got the basic idea.
So I think this is a great way to explore. So read the test to understand better how the library, how the project works, and write some tests just to write some tests. This is a great low cost place to try out your Clojure code. So writing some tests is a handy thing to do. Now, one other thing is handy here. As we mentioned, I can say Cider test, Cider test, run test, and run just one. And there we go. I've got just this one I'm working on right now. And this one test, I've got my result right there. And I want to see what's going on. So there we go. So again, these are the handler tests. And these match up if we go, well, let's see. So from what we mentioned earlier, do you think you can construct for me where the matching true source file is at?
Yeah.
Yeah.
So hopefully it's in source Clojure. And then I guess flats. And
There's a lot of stuff now. A lot of stuff.
Handler.
That's the one. So when you had tests that were failing, they're matching the functions right in here. So this is the way they're structured. So they line up. Okay, I want to talk a little bit more about one other thing about the structure. So here we are in the tests. We have the 3 kinds of tests. So as we mentioned, the unit tests are just to cover all of our functions. Is the function itself working like it's supposed to? Now, one of the great things about functional programming is that testing is very powerful in functional programming. So all I need to do is try a function and try the input, and is the output right? I need a lot less scaffolding than I would in an object-oriented setup where I've got to like meticulously build all these objects and classes and know their constructors and know their methods and all those things. I only need to know just plain old functions. I need to give it a map, and maybe I've got some raw data somewhere, that sample data that lets me fill those maps in. And I'll throw those at the functions and see if it works.
So does that mean there's not much mocking in your tests?
There's no. So the one we just showed you had some mocking for the handlers because it's mocking like JSON and stuff.
Right.
That is pretty much the only place we need literal mocking.
Right.
Yeah. So we do have false data that we can throw around, but we don't need mocking as much as a lot of other applications might. So one other thing just for the bookkeeping here. So mocking, Clojure also has rich support for generative testing, which is when you can say, hey, build me mocks. In fact, build me 2.5 million mocks and try them all. Mm-hmm. And Clojure has a way of doing that, so it can do that randomly. And there are some people who are a big fan of doing that instead of unit testing. They're saying, why are you doing like these individual pieces here? Like you're going to make what, three tests for a function when I could throw 1,000 tests at that function. So we don't do that much on this application, but it's an idea that has a lot of credence in the community. All right, so we got the unit test, and then we got the use case tests. So we mentioned reading your tests, see how things work. If you want the technical details, those unit tests are a place to go. Like, how does the actual function do stuff? But if you want a bigger picture, and that's why we call it stories here. If you want a picture of how do users actually wind their way through these functions, this is the place that's actually going to tell you more about that.
Okay.
So in this case, we don't have stuff testing the interface in here, the actual GUI, but we might have scoring. So okay, so somebody submits a test and maybe they fail everything. Then here's how we should be finding out it's a failure, and here's what should happen if it is. Because remember, these are language tests, so they're taking multiple choice questions, and they're supposed to get some number right or wrong. So if they all pass instead, if only half pass, and so on. That's it for this. That's for this namespace. That's all. So these are the stories here. And so that's the important distinction there, is we've got the unit and the use case. And on other applications, we have a little more UI. On this one, not so much, because it takes a long time and it's very brittle. So where we are a pretty lightweight front-end application, we don't worry too much about the UI tests. The one thing I'll show you here, again, in the unit tests, so you can see that we've got testing the routes, testing can they register, testing does the email system work, and then testing the DB. The various things testing the database there. Okay, I'm in the wrong place. Actually, I do want use case stories. Okay, so the important things here, we've got some things like the mail, but then we've got the exam test. So this is walking through a full exam to say, okay, these students are going to have an institution they're from. They're going to be somebody, a user. There's going to be a proctor. So this is where we are using some mock data. So proctor user map, that's mock data that we made, just a dummy proctor. Then we've got the registration. So that user is now registered. This did that in the database. It's going to be rewound after the tests, but it did it now in the fixture. Then we're going to do a test. In this case, we're doing Albanian. And so we create the exam in that test. So now there's one exam that one student's going to take. And we start going through the test. Now, remember that in these tests, oh, wow, this is a simple test here. It used to be more elaborate for this one, but we simplified it probably to make it shorter. But we have, for the sake of completeness, we have a test for every language. So let's go to every language that the flats test does. So let's go to the Albanian test. So this is the same setup as the last thing. So we start the Albanian, and then we've got one test here. And this is a big test because it's testing every single one of the 150 questions on the test. Now we set things up here to be relatively ambiguous here, but first we say when they start the test, it should play the audio for them. So we better be able to get that audio file. Does it exist? Okay, now they haven't done anything yet, so there should be no current question. And so on, all the way through. We get the next question, it should be this one, and we pick a wrong answer and a correct answer. We try them both, and so on. And then we just start stepping through. We go next question, next question, next question, all the way through. So to see how an actual test for an actual student works, go to the exams stories tests. All right. So that covers our test coverage here. Any questions you'd like to ask before we split?
I thought I had one a second ago, but no, I don't. Not that I can think of right now.
Okay. So the goal here is you should now be able to read these tests. Like start reading them, get familiar with the Clojure, maybe write some yourself if you want to, and these will help you understand how the whole application is put together.
Okay.
Yuri, do you have anything you'd like to add? No, I just say that test is really important. Like I had some time that I forgot to write a test first, and I had to write tests afterwards. But it's definitely better to write tests first.
Yeah.
And as we mentioned, we have CI/CD with Jenkins, and so it uses these tests. It expects the test to pass, or it won't deploy. So you need the test to be effective and good. All right, guys, thank you very much, and good luck moving forward.